first series of accidents occurred, killing 346 people, Boeing was almost in denial of any problems. This most recent problem, Boeing, to its credit, stepped up to the plate and they said, look.
Engineering challenges of building the world's longest airliner. Building the world's longest twin-engine airliner is no small feat. When you stretch an aircraft beyond a certain point, you run into all kinds of engineering challenges that don't exist with shorter designs. One of the biggest issues is structural flex. A longer fuselage means more bending and twisting during flight, especially during turbulence or hard landings. Boeing has to ensure that the airframe can handle these stresses without cracking or failing over thousands of flight cycles.
Boeing stock has also been on a decline and is down over 25% so far in 2024.
Then there's the issue of tail strikes. The longer the aircraft, the greater the risk that the tail will scrape the runway during takeoff or landing, especially if the pilots rotate too aggressively. Boeing will likely need to adjust the landing gear configuration, possibly adding additional support or changing the angle of the fuselage during ground operations. Weight distribution is another challenge. Adding length means adding weight, and that weight needs to be balanced correctly to maintain the aircraft's center of gravity. Too much weight in the back, and the aircraft becomes tail-heavy and unstable. Too much in the front, and it's harder to rotate during takeoff. The wings are also critical. The 777X already has the longest wingspan of any Boeing aircraft, and those wings need to generate enough lift to get the heavier 707-10 off the ground. The folding wingtip design helps with this, allowing the wings to be longer without exceeding airport gate limits, but it also adds mechanical complexity. And then there's certification. The FAA and other aviation authorities will scrutinize every aspect of the 707-10's design, from its structural integrity to its aerodynamics to its emergency evacuation procedures. Boeing will need to prove that this aircraft is just as safe and reliable as every other commercial jet in the sky.
That's the standard 777, no?
Well, actually, on the outside it is. But one of the things that Boeing did was to make the seats just a little bit wider.
So how does the 707-10 stack up against the competition? The most obvious rival is the Airbus A350-1000, the largest variant of the A350 family. The A350-1000 is a fantastic aircraft, efficient, quiet, and popular with airlines.
Boeing took a lot of shortcuts in developing this aircraft, and those shortcuts literally bit Boeing in its butt.
But it's smaller than the 707-10. It carries fewer passengers and has a slightly shorter range in most configurations. The 707-10 would offer more capacity, which is exactly what airlines like Emirates need for high-density routes. Then there's the Airbus A380, the giant four-engine super jumbo that was once the pride of Airbus but has since fallen out of favor. The A380 can carry more passengers than the 707-10, but it burns more fuel, requires 4 engines instead of 2, and needs specialized infrastructure at airports. Airbus has already stopped producing the A380 because airlines simply don't want it anymore. The 707-10 offers similar capacity with far better economics. There's also the 707-9, the 707-10's own sibling. The 707-9 is slightly shorter and carries fewer passengers, but it has better range. Some airlines might prefer the 707-9 for ultra-long-haul routes, while others might choose the 707-10 for high-capacity medium to long-haul flights. And then there's the Boeing 787-10, the longest variant of the Dreamliner family. The 787-10 is smaller and more efficient on certain routes, but it doesn't have the capacity or the range of the 707-10. They're different tools for different jobs. The 707-10 would fill a specific niche, high-capacity, long-range twin-engine efficiency. And right now, no other aircraft does that quite as well. So which airlines might actually buy the 707-10? Emirates is the obvious one. They've built their entire business model around high-capacity long-haul flights, and the 707-10 fits that perfectly. They already operate the largest 707 fleet in the world, and adding the 707-10 would be a natural extension of their strategy. Qatar Airways is another strong candidate. They operate a mix of A350s and 777s, and they've expressed interest in the 707X family before. The 707-10 would give them a high-capacity option for routes where the A350 to 1000 might be slightly too small. Etihad Airways, also based in the Middle East, could be interested for similar reasons. Then there are the Asian carriers. Cathay Pacific, Singapore Airlines, and ANA all operate large long-haul fleets and have historically been strong Boeing customers. They might see value in the 707-10 for high-demand routes between major Asian cities and destinations in Europe, North America, and Australia. British Airways and Lufthansa are possibilities in Europe, though European carriers have generally leaned more toward Airbus in recent years. In North America, carriers like United and American have large 707 fleets, but they've been shifting towards smaller, more flexible wide bodies like the 787. Still, if the economics work out, they might order a few 707-10s for specific high-capacity routes. The key for Boeing is proving that the 707-10 offers better economics than the alternatives and that it can actually deliver the aircraft on time. The 707-10 represents a specific vision of the future: high-capacity twin-engine efficiency and long-range flexibility. It's a bet that airlines will still need large aircraft to move hundreds of passengers on busy routes, but that they'll want to do it with 2 engines instead of 4. And that makes sense. The era of the jumbo jet is ending. The 747 is out of production. The A380 is done. Airlines want efficiency, and efficiency means fewer engines, lower fuel burn, and lower maintenance costs. But they still need capacity on certain routes.
The MCAS issue, the control system issue that they had on the MAX before, was in many ways more insidious because it was just a fundamental design flaw.
The 707-10 offers that balance. It's not as massive as an A380, but it's bigger than anything else with 2 engines. It's not as long range as the 707-8, but it's more than enough for most airline needs. And if Boeing can actually deliver it on time and on budget, it could redefine what a wide-body airliner looks like in the 2030s and beyond. Of course, there are risks. The aviation industry is unpredictable. Fuel prices fluctuate, demand shifts, new technologies emerge, but right now, the 707-10 looks like a solid bet. It's the kind of aircraft that could anchor airline fleets for decades, just like the original 707 did. With Emirates backing it, Boeing finally has the customer support it needs to make this aircraft a reality. The 707-10 isn't just another aircraft. It's Boeing's answer to a changing aviation landscape, a statement that twin-engine efficiency and high capacity can coexist. If Boeing can pull this off, it might just secure its place in the wide-body market for another generation.